Question 21. We have a diagram showing a trapezium ABCD. Lengths x plus 5 and x plus 8 are the parallel sides, and x is the height there. We're told that the area of this trapezium is 42. So the area of the trapezium is clearly going to be a formula that's involved here. Area of a trapezium is half of a plus b, that's the top base and the small base, top base and the bottom base added together, multiplied by h. You can also refer to this half a plus b as the average base, or the average width, the average of these two, that is, times height. We are being asked to show this. So they've just pulled a quadratic out of nowhere and asked you to show that. It's a very common style of these tricky types of questions. You're not expected to know in any way, shape or form where that's come from. You just got to go with the information the question gives you and create a formula, and then before you know it, substituting stuff in, you will get somewhere close to that. So it mentions the area of a trapezium, right? So the area of a trapezium, formula I've quoted there, that's where we start. We know the area is 42, so I can plug in 42 on the left hand side. Our a and little b, our top base and our bottom base, are x plus 5. I don't technically need these brackets because I'm just adding them together, but it's better to put them in than not. And our bottom base is x plus 8, and then we're multiplying by the height, which is an x, like so. Tidying up what's inside that bracket. So actually before that, just it's personal preference, I don't like the fact that we've got a half there, so I'm going to double both sides just to make it so that that half is gone. And then inside that bracket we're going to have an x plus an x for 2x. We're going to have a 5 plus an 8 for 13, and then we've got an x on the outside. If we break out that bracket now, we end up with 2x squared plus 13x, and then we're only one step away from what we need here, which is a 0. We have a 0 on one side, so if I take away 84 from both sides, then I will end up with this, take away 84, and that, although it's written the other way around, is us done. We've showed that equals 0. Part B. Calculate the perimeter of the trapezium. Now, the way you would start this question is you think, right, well, the perimeter, that's going to be all the sides added together. So what are those sides? Well, we have an x plus 5, we have an x plus 8, and then we have a, well, we don't know what that is, right? So if we kind of even add together what we have so far, we hit a dead end because of the fact that we don't know what that last length here is. But we also hit another dead end because we don't even know what x is yet. So even before we have this unknown, I'll just kind of add a little box here, before we have this unknown value there, we don't even know what x is. So we need to figure out what x is first, right? The last question gave us a quadratic equation. I mean, they asked us to show it, so that means they actually gave us this. If we solve that equation first and foremost, that will give us an x value, and then we're going to take the rest from there. So solving this quadratic, it is not a nice quadratic to solve. It does factorize nicely, so I'm going to go through the motions here to do that. To factorize this quadratic, we first of all start by doing a times c, 2 times negative 84, which will give us a negative 168. Now that negative basically tells us that we're going to have 1 plus and 1 minus, because you need that positive times a negative to get 168. Then we look at all the factors of 168. We have 1 in 168, 2 in 84, 3 in 56, 4 in 42, 6 in 28, 8 in 21, and I stop there because 8 and 21, one of them positive, one of them negative. That's how we're going to get that middle term there, 13x. Okay, 13x will be a plus 21x minus 8x. So we split that middle term up into 2 pieces. We leave our 2x squared at the beginning. We have our minus 84 at the end. We then take the first 2 terms and factorize the highest common factor out, which will be x, because nothing's in common between 2 and 21. That will leave us with this in the brackets. 2x plus 21 then will need to be what's left in the brackets after we take a highest common factor of these 2 terms. Now, the reason I say it has to be is because these need to match. So although it's not a natural thing to do when you factorize a highest common factor out, not only do we need to take out a number, but we need to take out that negative as well, because you'll notice both of those are negative, but these aren't. The 2 to an 8 is 4 for our multiple, so minus 4 is what's going to come out. And of course we can check it with that. That 84 is 4 times as big as 21. Then when we have that, our terms on the outside, that didn't work out, our terms on the outside are going to become the contents of one of the brackets, and the brackets here and here, if we take it out as a highest common factor from the whole thing, is what's going to give us the first pair of brackets here. So 2x plus 21 and x minus 4 is our fully factorized quadratic, after which we set each equal to 0 and solve. We will end up with x equaling minus 10.5 and x equaling 4. X can't be negative, so we basically rule that answer out. X can certainly be positive and it can certainly be 4. So we know that x is 4. Still not done yet. I mean, the fact that we have that 4 means we can update our perimeter. It's going to be a 4 plus 4 plus 5 plus 4 plus 8, but we still have that unknown that I highlighted there in red, this length that I'm about to draw here that we don't know yet. Well, hopefully, I'll be able to spot this. We have a right angle triangle in the making if we draw this. The fact that we know that x is 4 means that this length here is going to be 12 AD, and BC is going to be 4 plus 5 for 9, which means that this length left over here is going to be 3. Well, if that length there is 3, this height is 4, then by Pythagoras, very, very quickly, Pythagoras, we'll call it x. X squared is going to equal 3 squared plus 4 squared, which means x squared is 25. X is the square root of 25. X is 5. So we've got quite a nice Pythagoras problem here, a Pythagorean triple 3, 4, and 5. Even if you know that is 5, you should still show the workings here for where it comes from. But yeah, we now have that length, that missing piece here. Add 5 to that. Add all them together, and our perimeter is 30 centimeters, because all these measurements here were given in centimeters. 30 centimeters, done.